So now we're going to talk about definition of radical, which is the last rule. So we're going to name this definition of radical. So definition of radical is important as how I teach this question. Is actually something very easy. So a to the m over n equal to nth roots of a to the m. So first I have to explain this everything. This is an exponent, but this is a rational exponent, which is the fractions. But this is n over m. So what is n? In this case, n is the roots. And the m is the exponents, which is we know as a power. Okay, power. Now a lot of students get struggle with this because they don't understand what a basic thing is. We're going to talk about it too. So let's start by numbers. So 1 to the 1 power is 1. 2 power, sorry. 1 to the 2 power is 1. 2 to the 2 power is 4. 3 to the 2 power is 9. 4 to the 2 power is 16. And 5 to the square is 25. And 6 square is 36. 7 square is 49. 8 square is 64. 9 square is 81. 10 square is 100. 11 square is 121. 12 square is equal to 144. 13 square is 169. Now those numbers, I think all the students need to know. 14 square is 196. 15 square is 225. 16 square is equal to 256. And then 17, 18, 19, they're not important. 20 square is equal to 400. And 25 square is equal to 625. So let's go with 2 to the 3rd power. 1 to the 3 power is 1. 2 to the 3 power is 8. 3 to the 3rd power is 27. And the 4 to the 3rd power is equal to 64. And the 5 to the 3rd power is 125. Now let's go to 4th power. So 1 to the 4th power is 1. 2 to the 4th power is 16. 3 to the 4th power is 81. 1 to the 5th power is 1. 2 to the 5th power is 32. 3 to the 5th power is 243. I know this number looks really massive, but we're going to use this. Now, first of all, if you understand all those things, it's going to help you with a lot of radical problems and a lot of problems like this. It's called rational definition of radical. So what I told students is actually very easy to remember. Remember this, I'm going to draw an ugly tree, and this is a tree, and people are always like, this is not a tree, this is a light bulb. I'm going to write down a tree. There is a power. So power. And the roots here. So power over roots. So power over roots. Power over roots. Power over roots. Okay, so that's very interesting. So this is the rational exponent part, and this is the power, this is roots. Also, there's another name called index. Okay, and this is also called radicand, which is a very funny word to speak of, but that's not a very important thing right now. We just have to be able to solve this. So let's say if I had 125 to the 2 over 3, that I can rewrite to the 3rd roots of 125 and the square. But here's the thing, I don't know what's 125 squared because that's not one of the things I asked you to write down. But we can figure out what this is. Right here, we can say, well, in order to grow this tree, I need to make sure, in order to grow tree, you need to grow roots first. So what I'm gonna do is I'm gonna take the roots first. So I'm gonna take this part first, and we don't want to square, because when I square, I get a number I don't know. So what if I do roots first? The roots here is gonna be easy. That means which number multiplied by 3 times is gonna be, so it's cube root of 125. That means which number multiplied by 3 times, which is space times space times space, that's equal to 125. Well, we can look at it. Which one is 125? 5 to the third, which is 5 times 5 times 5. Therefore, this part is actually just 5. And the square, don't forget about that, is going to be 25. And that's a rational exponent. A lot of students have a problem with this question though. So 27 to the negative 2 over 3. So same thing. But what happened, we're going to go back and refer this rule here, negative exponent rules. So negative exponent rule says this is the numerator, and then we can change this to positive exponents. If I change this to positive exponent, then the thing can change. So that's going to be third roots of 27 according to the rational exponent rule here on the top. I can rework this. So first step is I'm going to change this negative to positive, change the denominator. So that's something I can work, because I don't like negative exponent. Nobody does. Okay. So then we can take care of this, and then we can say, well, let's do roots first. We talk about roots first. So what's third root of 27? Go back, 27, third root. So that means its answer is 3. So it's equal to 1 over 3 squared. That's equal to 1 over 9. Okay, those are the simple things. I also asked a lot of time that they have this question, so 3 to the negative 2 minus, let's say 8 to the negative 2 over third. This is the type of question I combine both negative exponential rule. This one's going to be 3 to the negative 2 power, that means 1 over 3 squared, minus 1 over 8 to the third root of 2. I'm going to take care of this part first. Third root of 8, that means 2 to the third. 2 to the third is 8. So that's equal to 1 over 9 minus 1 over 4. And that's going to be multiplied by 4 over 4. And that's 9 over 9. So that's equal to 36 over 4 minus 9 over 36. That's equal to negative 5 over 36. So that is put all the question combined together. And voila, I just explained the last rule here. I know it takes a while to explain this one, because this one seems to like a lot of people struggling. Algebra 2 students struggling, pre-calc students struggling, and calculus students struggling. So this is a really important rule by itself. And if you like it, subscribe me.